Communicating by laser is the next big step for space technology. Data moves at up to 100 times faster than radio waves. This is by Dan Gore, Real Clear Defense. Space is definitely the high ground when it comes to many military, scientific, and economic activities. As the world becomes more information intensive, the ability to move data rapidly, reliably, and cheaply will be of enormous advantage. Governments, private companies, and scientific organizations are rushing to build large satellite constellations to enhance surveillance of Earth, explore space, and improve the movement of data. Nations able to deploy robust space-based laser communications to systems will reap military, scientific, and commercial benefits. Government and private satellite networks are growing in capability and scale. Currently, there are about 4,500 satellites in orbit, the vast majority in low Earth orbit, LEO, but there are plans to deploy thousands more over the next few decades to survey both Earth and airspace and enhance reliable global communications as well. For instance, the U.S. Space Force is considering deploying two large satellite constellations, one to image the Earth and detect missile launches, and the second to facilitate global communications. As for the private sector, SpaceX Starlink Global Information Constellation could consist of up to 42,000 satellites, and these emerging networks will require faster, dependable ways of moving always increasing amounts of information around the world. At present, satellites rely on radio frequency communications, RF for short. This means they have limited data transmission rates. Exponential growth and information will cause these transmission networks to slow down. Satellite operators will also need a series of ground stations within line of sight of the satellites in order to provide two-way RF communications. And as satellites proliferate, their ability to communicate will run up against bandwidth limitations. In addition, as more satellites are deployed, the danger grows that their communication links will interfere with those of other nearby platforms. Space-based laser communication systems will be key to moving enormous amounts of data and communicating with satellites far out in space. Why use lasers, also referred to as optical technology, for communications? The essential answer is that they provide much higher data transmission rates, 10 to 100 times the rate available for radio frequency communications, depending on the type of laser. So this not only means a low cost to move information, but also much more information moved per second. Laser communication terminals also require less onboard power than do RF transmitters to send communications over great distance. So this means that space-based laser communication systems will be smaller and lighter than standard RF systems, opening up additional space and weight aboard satellites to deploy other capabilities. Laser crosslinks between satellites also allow for simplified architectures to control constellations with fewer ground stations. Efforts to interfere with U.S. military satellite communications by jamming RF transmissions are becoming commonplace. Fortunately, because lasers produce extremely narrow beams of energy compared to radio frequency communications, there is less chance of interference between satellites and the reduced ability for adversaries to intercept a communications link. In addition, by using laser crosslinks, the military can reduce the need to deploy satellite ground stations in locations that could be vulnerable to interference or attack. The U.S. is investing in a variety of laser communication systems to support scientific, military, and commercial activities. For scientific missions and limited applications on one-of-a-kind military satellites, the government can buy expensive, hand-built optical terminals. The challenge when planning proliferated architecture is building low-cost, low-power, dependable, and reconfigurable laser terminals. NASA is looking to employ laser communications to enhance the flow of information from space-based platforms and improve its ability to control satellites. The agency's Laser Communication Relay Demonstration, LCRD for short, seeks to develop laser communications with satellites in various orbits and future manned missions in space and to the moon. And NASA will also deploy its Deep Space Optical Communications Payload, DSOC for short, aboard the Psyche mission demonstrating the ability of lasers to facilitate very long-range communications. The U.S. military views space-based laser communications as vital to its ability to operate a distributed, multi-domain force able to share information globally down to the tactical edge in near real time. The U.S. Space Development Agency, SDA, is looking to build a large communications constellation called the Transport Layer. This constellation could consist of hundreds of satellites, providing that cheap and effective laser terminals are available. DARPA's Blackjack program is an attempt to address the demand for low-cost and readily configurable optical communication systems that will help various satellite constellations share copious amounts of data quickly and securely. Private companies are also deploying their own satellite constellations, some intended for Earth observations, others to provide low-cost global communications. For example, SpaceX Starlink satellite constellation is intended to provide worldwide access to high-speed internet. Starlink has begun to deploy purpose-built laser communication terminals on its satellites, starting with those in polar orbit in order to reduce the requirements for ground stations. Future tranches of Starlink satellites may all have laser crosslinks. Several U.S. companies are leading the way in the development of laser-based satellite communication systems. General Atomics is working with the SDA on laser interconnect and networking communication systems, LINCK, links for short, which will demonstrate secure optical communications in space. CACI International has been building a robust capability in laser communications, most recently with the acquisition of SA Photonics. DARPA recently launched 2 Mandrake satellites which employ SA Photonics CACI laser communication terminals. CACI also provides laser terminals for NASA's initial LCRD experiments communicating with platforms in LEO, that's low Earth orbit, as part of the Huma program and for DSOC program. So the race is on to equip future satellites with laser-based communication systems. As one space-oriented publication observed, this is the only choice for constellation building projects and deep space missions. The U.S. government and industry must continue to invest in the necessary optical technologies to create a robust and affordable domestic laser communications capability. This is by Dr. Daniel Grove on WND. Dan Gore, Real Clear Defense. Please leave your comments. Thank you for your support. Please support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.